Hi all, this is Mr. Yeager. We're looking at work and power today. So we're going to look at the concept of work and when is it done, as well as being able to calculate it. And then we're going to quickly look at the concept of power. Mainly it's just, the same thing as work, what it is and how to calculate it. So here we go. So I usually start off in class with just some visual examples of work being done. So we're going to kind of move on from that. Okay. Not examples of work would be running with a football, a dog, basically sitting in place, laying around, okay, and so forth. So here we go. So what is work? Work itself, the definition, work is done when a force is used to push or pull an object a distance. So you're going to see, when we get to the formula eventually, work is equal to force times distance. You need both of these to occur, okay? There has to be a force and the object has to move, okay? What work, I guess more specifically, it's how you are basically changing the energy or transferring energy into an object, okay? Work is the use of energy to move an object somewhere else. So the idea here that I always do in class is very simple. Is I grab my rolling chair. The rolling chair itself has no energy when it's just sitting on the ground at rest, when it's not moving. But if I apply a force and push it over a distance, the chair starts moving. Now the chair has kinetic energy, but where did it get that energy from? Me doing work on it. So work is where I am transferring some energy. What type of energy? Kinetic or potential usually, into the object. Okay, so work is energy. Okay, work is energy. I do want to write that down. Work is energy. So guess what? We're going to see later it is measured in joules. So it's another type of energy. The force and distance, in order for work to be done, the force and distance must both be horizontal together or vertical together. So they have to be basically in the same plane. They don't have to be in the same direction, but if they're both vertical, up and down, or left and right, horizontal, work is going to be done. So one of the first things we're trying to figure out is, how do I know that work is even done? And that can be tricky. Okay, how do I know work is even done? So, when I push a box across the ground, work is being done. Why? It's because I am applying a force and the object is moving horizontally. You can see I have velocity right here. Both the force and the change in distance is in the same direction. When that occurs, work is being done. When both the force and the change in position, displacement, is in the same direction, or both horizontal, work is being done. If they're in the same direction, we're going to say positive work is being done, which means you're adding energy to that object. This would be my example with the rolling chair. I'm pushing the rolling chair forward. It's moving forward. It's going to be moving faster and faster and faster if I keep on pushing it. The object will keep on getting more kinetic energy. Now, if the force and the motion is in opposite directions, like a car moving to the right but hitting the brakes, and there's friction, all right? They're still both horizontal, which means work is being done. I never said they had to be in the exact same direction, all right? If they're in the same direction, we're going to do positive work. Well, guess what? If they're in the opposite direction, what can you probably guess? They're doing negative work, okay? Because they're in the opposite direction of each other. What does negative work mean? Energy is lost, okay? It's decreasing. The object is decreasing in energy. The car is slowing down. If it's slowing down, what's happening to the kinetic energy? It's decreasing because there's negative work being done, okay? So if the motion and the force is in the same direction, it's positive work. If the force and the motion is in opposite directions, it's negative work being done. Same thing goes for vertical. I don't think I have examples of that, but if I'm lifting an object up, I'm applying a force up and it's moving up, that's positive work. If I'm lowering the object, I'm still applying a force up, but I'm moving that object down, it's negative work being done. Oh, so here we go. Yeah, sorry. I didn't know I had it. I should have paid attention there. So picking an object off the ground, force and motion is in the same direction, positive work being done. What type of work? Positive or negative? Positive. Okay. What about examples where there still is a force and there is a motion? Okay. It turns out just because the object is moving, that doesn't mean work is being done. So when is there not work? Okay. When is no work being done? There's a couple situations that are very, very common that we need to know. First, if you just carry an object across a distance, like this is where you're carrying a backpack or carrying a box in your arms or your books or whatever, your computer, you're carrying your phone, okay? If you carry an object, there's no work being done, okay? If the object doesn't move, there's no work being done. The silly example here is I always push against a wall. I could sit there and apply a force against the wall. I'm pushing it, okay? But does the wall ever move? No. So no work's being done. So in order for work to be done, the object does have to move. But just because it's moving doesn't mean work is being done, because when I carry an object, the object's moving, but we're going to see in a moment why no work is being done. When you carry an object, what's happening is maybe you're moving the object to the right. The object is moving to the right, but the idea is you're holding it, you're carrying it. So you are applying a force up to hold the object. I mean, it's in your hand, you feel the weight down, you're holding it up. The force and the direction of motion are not in the same direction. They're both not horizontal, they're both not vertical. So that is why no work is being done when you just carry an object. That is a big one that people struggle with, okay? When you carry an object, no work is being done. So what is the actual formula then? Pretty simple, okay? Work is simply equal to force times distance, okay? And so you just have to multiply the force and the distance together. We say work is equal to FD, all right? Force will be in newtons, distance in meters. Work is a measurement of energy, so we use the unit of joules. Work is in joules. So if we do a practice problem real quick, you push a car with 5,000 newtons of force, a distance of 10 meters, how much work is done? When you're given a word problem like this, don't worry about going, is it in the same direction? It's in the same direction. So we would just do force times distance, 5,000 times 10. You are putting in 50,000 joules of work to make that car move 10 meters. Done. You push a wall with 10,000 newtons of force, but it doesn't move. How much work was done on the wall? The answer is 0. You don't do anything. It's not moving. 7,000 joules was used to move an object 70 meters. How much force was applied to the object? All right, so for this one, look what I did. I'm giving you 7,000 joules, which means that's the work. So be careful, because some people will be like, oh, force times distance, just multiply the two numbers. You're in joules, so I'm giving you the work, I'm giving you the distance. So for this one, you got to rearrange the formula. It's going to be 100 joules. Why? Work equals force times distance. 7,000 equals force times 70. Divide by 70. Force equals 100 newtons. Okay? So just divide. You can use the whole triangle thing if it really helps you. The triangle would be work equals force times distance. I mean, that would be your triangle for this one. Force and distance are multiplied, so they're next to each other. Work is on top. You pick up an object with 50 newtons of force, 1 meter. You then carry the object 10 meters. How much work is done picking up the object? Well, if you're picking up the object, you're applying 50 newtons of force and moving it 1 meter, so that would be 50 joules, 50 times 1. How much work is done when you carry the object? Carrying the object. That means how much work is being done? 0. You don't multiply. What happens is people sit there and multiply 50 times 10. They go 500. I don't get it. You are carrying the object. When you carry the object, there is no work being done. Okay? So please be careful of that. In these problems, you're going to be looking at, is work being done? Yes or no? Okay? Possibly whether it's positive or negative. That's not as likely in physical science. All right? But it's good to already kind of figure that out, maybe if you move into physics. But recognize if work is being done, understand why it is or it is not being done, and then be able to calculate it. Second part of this, what's power? Okay. Power is the rate at which work is being done. In other words, how quick are you in converting that energy? How fast do you do it? So the formula for work is work divided by time. Power, so in symbol form, that would be P equals W divided by T. Work has to be in joules. Time has to be in seconds. Okay? Make sure you recognize that. Time has to be in seconds for this. All right? That's because the unit for power is the watt, and a watt is equal to, oops, come on thing. A watt is equal to a joule divided by a second. Joules divided by seconds. Okay? So that's a watt. So here's already a quick problem. A light bulb does 200 joules of work in 2 seconds. What's the power of the light bulb? Well, you're given the work, you're given the time. Formula is work divided by time. 200 and W is 200 and T is 2 seconds. P is equal to 200 divided by 2. Power is equal to 100 watts. Now I know this is annoying because this is where a lot of people are like, what's with all the W's? This W is work. But then when you put it after a number, this is the unit watt. Okay. That's it. You just have to divide the two. If we want to use it in a formula, in a triangle, this would be work over time equals power. So power and time are on the bottom, work is on top. Okay. Work has to be above time. So here's kind of just a more conceptual question with it. Why is a 120 watt bulb brighter than a 60 watt bulb? It's because a 120 watt bulb is producing 120 joules of energy every single second, while a 60 watt bulb is producing 60 joules of light energy every single second. It's producing more light energy. That's why it is brighter. Okay. In a shorter period of time. Last example, a crane lifts an object up with 500 newtons of force, a distance of 10 meters in 5 seconds. So you're given a lot of stuff here. What is the work done on the object? Okay, so it says 5,000. How the heck did I get that? I'm given the force, I'm given the distance, and I'm given the time. Work is equal to just force times distance, so I just need the force and the distance. 500 times 10 equals 5,000 joules. What's the power of the crane? Power is equal to work divided by time. I found the work, 5,000 joules. How much time? 5 seconds. So this would be 1,000 watts. 1,000 watts. So, I mean, the only tricky things that can happen here, you just don't read correctly. You misunderstand what's being given to you. Make sure you know your units well. Formulas are all given to you. So just identify what's involved, what's given in the problem, plug it into the formula, and solve. You're good to go. And that's about it, I think. Yep. Thank you very much.